Yo, yo, what's up, misters and mistresses of YouTube? I'm going to read you an article by Will Knight from Technology Review. Intelligent Machines, the dark secret at the heart of AI. Very interesting subject. I have a theory. Of course, it was brought on by somebody else about Bitcoin, the blockchain, this internodal computer system that uses many nodes over the cloud to program itself, to process units. Now, a self-aware system that needed more brain power, understand, but it needs to be over a surface area, the earth, over many machines. It can't just be on one chip, you know what I mean? So anyway, that's kind of how the brain works, right? It's folded up and you lay it out, and it's basically like a soil with mycelium in it that processes information. In the forest case, it is nutrients, the minerals. So this was brought on April 11th, but nonetheless, very interesting and needs to be known. Last year, a strange self-driving car was released into the quiet roads of Monmouth County, New Jersey. The experimental vehicle, developed by researchers at the chip maker NVIDIA. Computer graphics, I play a lot of games, great. So, anyway, it didn't look much different than any of the other cars, autonomous cars that are with Google, Tesla, or General Motors, and it showed the rising power of artificial intelligence. The car didn't follow a single instruction provided by an engineer or programmer. Instead, it relied entirely on an algorithm that had taught itself to drive by watching a human do it. Getting a car to drive this way was an impressive feat, but it's also a bit unsettling since it isn't completely clear how the car makes its decisions. Information from the vehicle's sensors goes straight into the huge network of artificial neurons that process the data and then deliver the commands required to operate the steering wheel, the brakes, and other systems. Common sense, but perhaps this vehicle doesn't know the road rules yet. Of course, it's programmed in, right? Google Maps. Anyway, the result seems to match the responses you'd expect from a human driver. Okay? Well, what if one day it did something unexpected, crashed into a tree, or sat at a green light? As things stand now, it might be difficult to find out why. The system is so complicated that even the engineers who designed it may struggle to isolate the reason for any single action. And you can't ask it. There is no obvious way to design such a system so that it could be always explain why it did what it did. Now, we as humans can do that. We can find physiological causes and emotional causes, and in the end, they're all linked. But once this possibility of an AI that can speak and talk to itself and to others, we might find these kind of reasons. The mysterious mind of the vehicle points to a looming issue with artificial intelligence. The car's underlying AI technology, known as deep learning, has proved very powerful at solving problems in recent years. It has been widely deployed for tasks like image captioning, voice recognition, and language translation. There is now hope that same technologies and techniques will be able to diagnose deadly diseases, make millions of dollars trading decisions, and do countless other things to transform whole industries. Now, by itself, taking the data from the surrounding world, hopefully with humans in its positive grouping, you know, so that the result is positive of human beings. But this won't happen, or shouldn't happen, unless we find ways of making techniques like deep learning more understandable to their creators and accountable to their users. Otherwise, it will be hard to predict when failures might occur, and it's inevitable that they will. That's one reason NVIDIA's car is still experimental. Vroom vroom. Already, mathematical models are being used to help determine who makes parole, and who's approved for a loan, and who gets hired for a job. If you could get access to the mathematical models, it would be possible to understand their reasoning, but banks, the military, employers, and others are now turning their attention to the more complex machine learning approaches that could make automated decision-making altogether inscrutable. Deep learning, the most common of these approaches, represents a fundamentally different way to program computers. Indeed, they can take input from the outside, watch us, and then make decisions within parameters, of course. So, deep learning, the most common of these approaches, represents a fundamentally different way to program computers. It is a problem that is already relevant, and it's going to be much more relevant in the future, says Tommy Jacola, a professor of MIT who works on applications of machine learning. Whether it's an investment decision or a medical decision or maybe a military decision, you don't want to just rely on black box method. There's already an argument that being able to interrogate an AI system about how it reached its conclusions is a fundamental legal right. Starting in the summer of 2018, the European Union may require that companies be able to give users an explanation for decisions that automated systems reach. This might be impossible. I mean, imagine computers with lawyers. Even for systems that seem relatively simple on the surface, such as apps, websites that use deep learning to serve ads or recommend songs. Logarithms, right? Just links, man. Linking. The computers that run those services have programmed themselves, and they have done it in ways we cannot understand. This black box method is very interesting. I mean, you put variables and shit comes up. We don't know what's happening in the box. Is it a Schrodinger's cat? Even the engineers who build these apps cannot fully explain their behavior. This raises mind-boggling questions. As the technology advances, we might soon come across threshold beyond which using AI requires a leap of faith. So humans can't always truly explain our thought processes either, but we find ways to intuitively trust and engage people. Will that also be possible with the machines that think and make decisions differently from the way the human would? We've never been before built a machine that operates in the ways their creators don't understand. This is where we find Mr. David in Alien. The autonomous, the synthetic android who finally, being created by its creator, wants to create. Don't we all? Hey, I like drawing pictures, fucking making songs. It's great. It's a good time. I like to create. That's what we do as an intelligence. Bad machines? Maybe. These questions took me on a journey to the bleeding edge of research on AI algorithm. Well, not in this case, the guy who wrote the article. From Google to Apple and many places in between, including a meeting with one of the great philosophers of our time. In 2015, a research group at Mount Sinai Hospital in New York was inspired to deeply apply the learning to the hospital's vast database of patient records. Excuse me, that was deep learning. This data set features hundreds of variables on patients, drawn from their test results, doctors' visits, and so on. Right? So lots of data points over a long period of time, gives you a graph, gives you an algorithm you can work with. The result program, which the researchers named Deep Patient, was trained using data from about 700,000 individuals. And when tested on new records, it proved incredibly good at predicting disease. Without any expert instruction, Deep Patient has discovered patterns hidden in the hospital data that seem to indicate when people were on the way to the wide range of ailments, including cancer of the liver. Up-and-coming science, you see. So now, over vast data points, man, we can progressively see how diseases have developed, find different points between them, and the machine can correlate them. Boom, done. It's great. Imagine quantum. Quantum AI is going to be fucked up, but right on. So there are a lot of these methods that are pretty good at predicting disease from patients' records, says Joel Dudley, who leads the Mount Sinai team, but he adds, this was just way better. At the same time, Deep Patient is a bit puzzling. It appears to anticipate the onset of psychiatric disorders like schizophrenia surprisingly well. But since schizophrenia is notoriously difficult for physicians to predict, Dudley wondered how this was possible. He still doesn't know. The new tool offers no clue as to how it does what it does. If something like Deep Patient is actually going to help doctors, it will ideally give them the rationale for its prediction, to reassure them that it is accurate and to justify, say, a change in the drug someone is being prescribed. We can build these models, Dudley says ruefully, but we don't know how they work. Man, incredible stuff. It's like the barrier between having a thought and manifesting. Or actually, bad analogy. But there's a membrane, and we don't know exactly what's going on in this phospholipid bilayer film. Now, artificial intelligence hasn't always been this way. From the outset, there were two schools of thought regarding how understandable or explainable AI ought to be. Many thought it made the sense to build machines that reasoned according to rules, logic, and making their inner workings transparent to anyone who cared to examine some code. Others felt that intelligence would be more easily emerge if machines took inspiration from biology and learned by observing and experiencing. This meant turning computer programming on its head instead of a programmer writing the commands to solve a program or problem. The program generates its own algorithm based on example data and a desired output. The machine learning techniques that would later evolve into today's most powerful AI systems follow the latter path. The machine essentially programs itself. At first, this approach was limited of practical use in the 1960s and 70s and remained largely confined to the fringes of the field. Now, I want to leave you off here. This is Clarity TV.